أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. This lecture is about the statistical data analysis. Whenever you collect the data through your questionnaire, through your interviews, or using other source, you have to analyze then the data, whether it is qualitative or it is quantitative. Qualitative data is somehow a difficult task to be analyzed, whereas quantitative data has got its own method of analysis. Whenever you collect a raw data in the form of questionnaire, when you get it filled from your participants or from the individual of your study, you have to organize your data and then you have to apply some statistical test as necessary according to your research topic. So let me share first the slides, and then I'll be explaining each and every slide how to analyze your data when your research topic is a quantitative one. When you use a quantitative data, quantitative study design. So let me share you first the slide, and then we will inshallah discuss how to analyze the data. This is data analysis plane. First, you have to analyze your data through descriptive statistic. And what is descriptive statistic? What is inferential statistic? Descriptive statistic or all those calculation are statistic that describe your samples. Like how many males are there, how many females are there. If you have studied the continuous variable, what is the standard deviation? What is the variance? What is the mean, median, and mode? What is the quartile deviation? What is percentile? All these are descriptive statistics. So if your outcome, it totally depends upon your statistical analysis, depends upon your outcome variable. Whether your outcome variable is a quantitative one or it is a categorical variable, it totally depends upon it. And for qualitative variable or categorical variable, there is separate statistical method, whereas for quantitative or continuous variable, there is a separate statistical method. So suppose your outcome variable is a categorical one. So what would you do with that categorical variable? For example, if I throw a question on a participant or to a participant, do you smoke? Yes or no. So the answer is in yes or no, that is a categorical variable. But if I ask the participant, what is your age, or tell me your age, and if I write it 30 years, 25 years, 40 years, whatever the age and years is, that is then a quantitative one. So the quantitative descriptive statistics are different from the categorical statistics. So let's discuss what are the categorical statistic or analysis. If you have a categorical variable, then you have to organize this data, or you have to describe your sample in the form of frequencies and percentages. And if you have quantitative variables, then make sure you have to go for measure of central tendency, that is summary of your data set of your sample, and you have to calculate mean, median, and mode. And other measure of statistic or analysis are variation and dispersion, and that includes your range, variance, standard deviation, and coefficient of variation. So all these two types are the descriptive statistic. If your outcome variable is a categorical one, you have to go for frequencies and percentages. For example, how many males are there, how many females are there, What is the percentage of male? What is the percentage of female? And here in quantitative, you have to summarize your data or your sample size in the form of mean, median, and mode. And if you go one step ahead, there are other measures as well. For example, measure of variation, measure of dispersion, which include range, variance, standard deviation, and coefficient of variation. So all these are descriptive statistics. Measure of central tendency tells you the middle values of the data set, which summarize your data in single values, whereas measure of dispersion or variation tells you or give you information about the spread of the data, how much spread is there in your data set. Now coming to the inferential statistic, this is the second part. If you have a research question in which you have to test a hypothesis, then you have to apply the inferential statistic. And again, it depends upon your outcome variable. The variable that you are going to test in your hypothesis, that is your outcome variable. So if your outcome variable is a categorical one, then what you have to do, if you have two or more groups, you have to apply chi-square test for categorical variable, and chi-square test tells you whether there is an association between the two categorical nominal variables or not. For example, if you want to see or to determine an association between smoking and the disease, then your one categorical variable may be like, do you smoke, yes and no? And you can ask about the disease, whether a person who is smoker or who is non-smoker, he has developed or he has not developed the disease. So disease positive and disease negative, between the disease and smoking status, you can determine an association. And if there is an association, you will get a p-value less than 0.05, which will tell you that there is a difference in the disease development between smoker and non-smoker. Means the people who smoke more, they are likely to develop the disease, and the people who do not smoke, they are less likely to develop the disease. So that is for categorical variable. And in categorical variable, you can apply for categorical variable a chi-square test, but one step ahead, you can also go for Fisher exact test, and that test is applied when you have a 2x2 table and your expected frequency in a 2x2 table is less than 5. Then you can go for Fisher exact test. Like you have got, let me draw a 2x2 table, and I will explain it. For example, this is a 2x2 table. This is smoking status. Smoking status, whether the individual that you are going to conduct a research study on them, they smoke or so. Some may say yes, some may say no in your sample. And this is the disease. The disease may be the lung cancer, it may be blood pressure or whatever, positive or negative. For example, 50 people said there were 100 people. This is the total. Out of 120 people, 50 developed the disease and 70 did not develop the disease out of 120 who were smoker. And in no smoker, 30 developed the disease and 90 did not develop the disease. They were also 120. And if you calculate chi-square test with this formula, sigma O minus E whole square divided by E, with this formula, and you get a p-value which is less than 0.05, it means that there is an association between disease and the smoking. The people who smoke more, they are likely to develop the disease as compared to those people who do not smoke. And you get a p-value less than 0.05, mean there is an association between smoking and the disease development. Now, if you calculate the expected frequency, these are the observed frequencies. These are the observed frequencies in cell A, this is B, this is C, and this is D. If the expected frequency that we calculate through a formula, if the expected frequency in any of these cells is less than 5, the expected frequency is less than 5, then you will not apply chi-square test, but you will go for Fisher exact test. Fisher exact test, which compensate the small expected frequency of the cell and give you a result which you may generalize to the population from where you have taken the sample. So this is what the explanation of Fisher exact test. When we apply Fisher exact test, if we do not have an expected frequency 5 or more than 5 in a cell, but it is less than 5 in any cell, or 20% of the cell, if this is not a 2 by 2 table, but there are many rows and many columns, and there are multiple cells, and 20% of the cell, they have less than an expected frequency of less than 5, then you will go for Fisher exact test rather than chi-square test. And this is for categorical variable. And if you have a quantitative variable, whether the quantitative variable is parametric, parametric means you have collected the sample from the normally distributed population, and if your population is normally distributed and the test we apply, those are called parametric tests. So if you have two groups, like you have two groups in your sample, means you have collected the sample from two independent population, then you have to apply independent sample t-test. And if you have more than two groups, then you have to apply ANOVA, which is analysis of variance. And there are three types of ANOVA. One is one-way analysis of variance, where you have one independent variable and one outcome variable, where the outcome variable is a continuous one. And there are two-way analysis of variance, where you have one continuous outcome variable and two categorical variable. And if you have more than two categorical variable as independent variables, then you have to apply multiple analysis of variance, which is called MANOVA. And if you have got a single sample and you want to assess or determine the difference before and after the intervention, then you have to apply pair sample t-test or pair t-test. On the other hand, if you have an outcome variable which is quantitative, but your data is not normally distributed, then you have to apply non-parametric test, where you cannot apply a not normally distributed population, you cannot apply the parametric test. You have to apply these non-parametric tests on the population where it is not normally distributed. So if there are two groups, instead of independent sample t-test, you have to apply Mann-Whitney U-test. And if there are more than two groups, instead of ANOVA, one-way analysis of variance, you have to apply Kruskal-Wallis test. And if you have before and after sample, instead of pair sample t-test, you have to apply Wilcoxon-Sign rank test. This is not McNemar test, but you have to apply Wilcoxon-Sign rank test. So let me clear it. Here it is written McNemar test, But a McNemar test, we apply on categorical variable where you have before and after the intervention, but you have got frequencies. Like for example, if the motorcycle biker use the helmet, your answer is yes and no. So before using the helmet and after using the helmet, where there is a difference in the road traffic accident or not. So that is also one sample, but before and after you are testing whether there is an association between wearing of helmet and the accident, the head injuries. Then you have to apply McNemar test, and which is on categorical variable rather than continuous variable. So here you have to apply Wilcoxon sign rank test instead of McNemar test. Let me write the McNemar test. Instead of McNemar test, there is a mistake. You have to apply Wilcoxon sign rank test. Wilcoxon sign rank test. That is instead of McNemar. This test is applied when you have a single sample and you want to see the difference in the frequencies before an intervention and after the intervention. Then you have to apply Wilcoxon sign rank test. So this was all about the data analysis. There are other non-parametric tests. There are other tests that we can apply while we are analyzing our data. But inshallah, we will be doing all these tests, parametric and non-parametric tests, in the upcoming lectures. So if you have any question, or if something is not clear to you, you can write in your comment box, and inshallah you will get a satisfactory answer for that. So thank you very much. Do evaluate or give me your feedback so that I can improve the strategies of delivering the lecture. Thank you so much.